Okay, today we're doing lesson 4.8, module 4, lesson 8. And your learning goal today is to be able to explain to someone else how multiplying a fraction by a whole number is the same or related to repeated addition. Okay, but first let's talk about the problem of the day. We've talked on and off about converting units of measurement. Remember, we can measure length, we can also measure volume, and we can also measure weight, right? Over here, what measurements do you see? Feet and inches. Was that measuring length, capacity, which is volume, or is it measuring weight? Length, okay. So help me out. 1 foot is the same as how many inches? 12. Okay, so then 2 feet is the same as how many inches? 3 feet is the same as how many inches? And then 10 feet is the same as how many inches? Okay. When we convert from feet to inches, are we converting from a bigger measurement to a smaller one, or a smaller one to a bigger one? Nice. So is the answer getting bigger or smaller than our original number? Bigger. Nice. Remember when we talked about this a long time ago? Yeah. Just because we talked about it back in October and November, does that mean we can forget about it and dump that out of our brains? No. That stuff, all this stuff is going to come back over and over again in your life. Okay, let's look at this one. Here we have yards and feet. Are these measuring length, weight, or volume? Length. Okay, help me out. 1 yard is how many feet?
3.
2 yards is?
6.
5 yards is? 15 feet. And 10 yards is? 30 feet. Nice. Okay, let's try another one. Oh, here we have gallons and quarts. What are we measuring here? Length, weight, or volume? Volume. Nice. Okay, 1 gallon is how many quarts?
4.
Good job, guys. Okay, then 2 gallons is? 8 quarts. And then 8 gallons is? 32. How are you converting? How did you go from 8 gallons to 32 quarts? Junebach?
Since 1 gallon is 4 quarters.
Quarts, you mean?
Yeah, quarts.
Uh-huh.
If you do 8 gallons, then you just need to do 8 times 4.
Yeah, because we know in each of those 8 gallons there's 4 quarts. Nice. Okay, let's do one last one. Okay, here we have pints and cups. What are we measuring this time? Volume again. Good. 1 pint is how many cups?
2.
So 2 pints is 4 cups. So then 9 pints is?
18.
Nice. Okay, good job. So, as I mentioned, I want you to write this stuff down. 2 times 6 we know is the same thing as 6 times 2 because of the commutative property of multiplication. Kevin, go ahead and write this down. Now, we know that 2 times 6 means 2 copies of 6, or 6 plus 6. We know that multiplication is the same as repeated addition. Therefore, when we switch it around using the commutative property and have 6 times 2, that means 6 copies of 2, or 2 plus 2 plus 2 plus 2 plus 2 plus 2. We're going to add 2 repeatedly 6 times. The same thing works when we have fraction and whole number multiplication. Just look at the top part right now. Do you guys agree that 2/3 times 6 is the same thing as 6 times 2/3?
Yeah.
And we know, let's just look at the left side now. We know that 2/3 times 6, is that the same thing as 2/3 of 6?
Yeah.
So I drew a tape diagram where the whole piece of tape was 6, and you can draw this in just a moment too. And then I divided it into thirds because I'm trying to find 2/3 of it, which is this portion. Yes? Then I could say that 3 units equals 6, so therefore 1 unit equals what? 6 divided by 3, which is 2. But I want to find 2/3 of it, or 2 units, so then if 1 unit is 2, 2 units equals 2 times 2, or what? 4. Okay? Is this left side over here? This is what we did yesterday, right? For our homework. Do you guys remember that?
Yes.
Good. But today we're going to relate it to repeated addition. So when I use the commutative property and do 6 times 2/3, is that the same as 6 copies of 2/3? So that's the same thing as 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3, right? How many times did I have to repeatedly add 2/3? 6 times, yeah. Now, are we ready to add these fractions? What helps us figure out if we're ready to add fractions? We need to look at the denominator. Are the denominators all the same?
Yeah.
So if they're all the same, is that the same as 2 plus 2 plus 2 plus 2 plus 2 plus 2 all over 3?
Yeah.
So is that the same thing then as 2 times 6 over 3?
Yeah.
Right, okay, so then what's 2 times 6? 12 over 3. Can I simplify 12/3?
Yes.
What do I get?
4.
4. So do I get the same answer?
Yes.
Huh. Okay, so we're starting to see how what we did yesterday is related to repeated addition. In order to find what 3/5 of 10 would be, we have to draw a piece of tape. And the whole tape is how long? 10. And we have to divide it equally into how many sections? 5. 1, 2, 3, 4, 5. Okay, and then we're trying to find how much? 3 of those sections. Okay, so let's start figuring out using the units. How many units do we have altogether? So we can say 5 units is how long? Equals 10. So then 1 unit would be 10 divided by what? 5, which is 2. But we're trying to find how big, how many units are? 3. So next thing we write is 3 units equals 2 times 3, which is 6. Okay, so we think our answer is going to be 6. But let's try it the other way. Should we get the same answer if we do 10 times 3/5?
Yes.
Okay, let's see. Now, 10 times 3/5 is the same as 10 copies of 3/5, isn't it?
Yeah.
So if I'm going to use repeated addition, I would do 3/5 plus 3/5 plus 3/5 dot plus dot dot dot. How many times would I do it? How many times would I need to add 3/5 to each other? 10 times, right? Now, would we be ready to add right away?
Yeah.
How do we know?
Because the denominator.
The denominator is the same. So, do I know when I add it, my denominator is going to stay the same?
Yeah.
It's going to be 5, right? And on top, what would I do? I would do 3 plus 3 plus 3 plus 3. How many times? 10 times. So is that the same thing as 3 times 10 on the top for the numerator over 5 as the denominator? Good. What is 3 times 10? 30 over 5, which is 6. Did we get the same answer?
Yeah.
Yeah. Okay, so we can see how the repeated addition is related to the tape diagram. So to review what you should have learned in 4th grade, because this is a 4th grade math standard, when you have numbers in the numerator and the denominator with a common factor, you can go ahead and divide, as long as you divide by the same number in the top as you divide by the same number in the bottom. So, for example, is 24 a multiple of 6?
Yes.
Is 6 a multiple of 6?
Yes.
So we can say that 24 and 6 have a common factor of what? 6. So what that means is what I can do is I can divide something in the numerator by 6. What's 24 divided by 6? 4. I can write 4 there instead, as long as I also divide something in the denominator by the same number. So what did I divide 24 by? 6. So that means I need to divide the 6 by what? 6, which is 1. So now my new problem is 7 times 4 over 1. Does that make sense? Is that easier to do now? What's 7 times 4?
28.
What's 28 over 1?
28.
28. So therefore, 24 copies of 7/6 would be 28. Okay, but that's only half of what we're doing. This is the repeated addition half. Now let's do the tape diagram half as our whole, and we labeled it on our piece of tape. Now, we need to divide this equally into how many units? 6. So let's go ahead and do that. 2, 3, 4, 5, 6 units. Let's first figure out how big 1 unit is. Okay, so we can write 6 units equals 24. So therefore, 1 unit is going to be 24 divided by what? Divided by 6, which is what? 4. And if we're trying to find 7/6 and 1 unit is 1/6, we have to multiply that 1 unit by how many times? 7. So then you're trying to find how much 7 units would be. Does that make sense? So I could do that by doing 4 times 7, which is 28. Do you guys see that you got the same answer both ways? Good.